One of the most common pitfalls in using OpenCV is memory leakage, and it builds up after you use your program. So let me show what I mean. My program over here. So I'm going to run my program over here. Hello, as you guys can see me. So I want you to focus on something over here. You can see on my right hand side here. The memory is increasing linearly, and then the buffer size is also increasing. So the problem with this program is that the memories will just always increase because we don't have a way, the buffer size is not bounded. Latency will always increase over time as our memory keeps on increasing. So this program, at one point, it is dependent on the amount of memory you have in your device, be it a CCTV camera, your computer, whatever you're using to run your program. So the memory just keeps on increasing. I'll stop this program to show you the fix. So I'll come over here and then change the fix on the one that we have a queue inside, and then I'll run it. Now, watch over the graph over this side. The graph is fluctuating. You can see it over here. The buffer is memory 8, and then it is fluctuating. Okay. So that means we have already managed how it is. So this program can run for a long time, streaming. That's a possibility. So the advantage of this one is that it's possible for you to live stream. The disadvantage of it is that you will be losing more frames as time progresses. But if your target is to live stream and capture things in real time, maybe you are doing some computer vision in real time. This is the approach that I'm currently using. So let me show you what is happening, what causes the difference between these two programs. So to start with, I'll go ahead and start with the one with the bug. So let me scroll all the way to the top. So there's something that you have to understand over here. When you're capturing these frames, you're capturing them in real time. For you to display them, you have to store them somewhere. And where are you storing them? You're storing them in a list over here. And my list is called frames. So it is unbounded. This means that it just keeps on storing without having any limitation in the amount of frames that you can store over here, there. So over time, this one builds up in memory. Okay. So let me show you. So first of all, as you know, we capture the camera feed or the source of your file so that the next function that is read can be able to capture the frames. Now, once it captures the frames, what does it do? It displays them over that side. Okay, so this is what you see over. You saw me. So those are the frames that you see. So once all of them are being captured, for this program to be able to maintain a seamless transition in terms of frames, we store them somewhere. So where do we store them? In this situation, we store them inside the frames. So as you can see, we append them inside this frame, and then the count of frames keeps on increasing as time progresses. So this is where the leak happens in this area. Okay, and then this one releases once you control LC, it will stop the device, and then the memory will be released. So that's one thing that you have to see over there. So that is the problem that is happening in this program. Let me show you what the fix. In the fix overside here, the first point we have is we need to bound a number of frames that needs to be on the list. You can see over here, I'm using a queue. Okay, so this one, the maximum number of frames is 8. You can see over here, and then we add them inside the queue. Queue is a data structure. That means that the first frame that came in will be the first in, first out. The first one that came in is the first one that will get out of the queue. Okay, and then let's go to the next point. Now here we capture, as you know, all of them we have to capture the video sources. You can see over there, if an error occurs, it says that it could not open, and then we read the frames. This is the frame reader. reader. So it goes ahead and there's the frames, and this one is what you see in the live stream. And then, now what is the fix? The fix happens at this point. So we capture the frames over there. So when the list is, so when full, it removes the all frames inside the queue. That is the first one that came in, the first one that will be out. But our memory of the frame will always remain to be the same as the maximum number of size. So this is the trade-off that you have over there. It can sustain a very large overload over time, but when you need to display, so what is happening here is that when you need to display a long video streaming, you need to drop some old frames as time progresses. So that is one thing that we have over here. So you can see over here, that is what is happening on this side. And then I need to show you something. So once we release them, that means our memory becomes stable. That's what causes the clustering on the other side. So how do we achieve this? So we have a function here, get frames. Okay. What does it do? The consumer removes frames from the get function. So once we have already processed the frames, you don't have to store them anywhere. So it will be released from the buffer. Okay. So let me show you what is happening, so that you can, let me run the program again so that you can see the difference of what is happening. So I'll go back to the one that is fixed. Then run it. Now look, it grows to a certain amount, then it plateaus. So it is trending. Okay, that means the number of frames that we are storing in our memory is the same. The one that came in, the oldest one that came in is the first one to get out. Then it's streaming. Then go back to our old way of doing things, the one that's unbounded. Now look, it just keeps on increasing, So the live streaming at one point will just be related to the amount of memory you have in your device. Okay? So thank you guys. In the next program, I'll show you how we can go ahead and use this program in the fifth version of it. The fifth version in live detection program. Thank you.